We often take our bones for granted, these silent guardians that provide the framework for our bodies. Hidden beneath layers of skin and muscle, they are easy to forget. Yet bones are marvels of engineering, strong enough to support our weight, yet light enough to allow movement. They are living tissues, constantly renewing themselves, and play a vital role in our overall health. Without bones, we wouldn't have the structure to stand, the dexterity to move, or the protection for our vital organs. Bones are the silent storytellers of our past, revealing clues about our ancestry and evolution. They bear the marks of our activities, our injuries, and even our diet. Understanding bones is not just about memorizing names and locations. It's about appreciating the intricate design and essential functions of these remarkable structures that literally hold us together. From the delicate bones in our inner ear that allow us to hear, to the powerful femur that supports our weight with each step, the human skeleton is a testament to the power of natural selection. It is a complex system, perfectly adapted to meet the demands of our daily lives. In this exploration, we'll delve into the fascinating world of bones, uncovering their secrets, their functions, and their importance in the grand scheme of human biology. Prepare to be amazed by the hidden wonders within your own body. Section 2. The marvel of bone structure. A closer look. Bones may seem solid and unchanging, but they are far from inert. They are living tissues, buzzing with activity, constantly remodeling themselves to adapt to changing needs. This dynamic nature is what makes bones so resilient, able to repair themselves after injury and adjust to the stresses and strains of daily life. A closer look at bone structure reveals a complex composition, a marvel of biological engineering. The outer layer, known as compact bone, is dense and hard, providing strength and protection. Beneath this lies spongy bone, a honeycomb-like structure that provides lightweight support and houses bone marrow. Bone marrow, the soft tissue found within the cavities of some bones, is essential for the production of blood cells. This vital process, known as hematopoiesis, ensures a constant supply of red blood cells for oxygen transport, white blood cells for immunity, and platelets for blood clotting. The intricate structure of bone, with its combination of strength, flexibility, and lightness, is a testament to the elegance of natural selection. It's a perfect example of how form follows function in the human body. Section 3. Bone functions beyond structure. While their role in providing structural support is well known, bones do much more than just hold us upright. They are multifunctional organs, essential for a wide range of physiological processes that keep us alive and functioning. One crucial function is the protection of vital organs. The rib cage shields our heart and lungs, the skull encases our brain, and the vertebrae safeguard the delicate spinal cord. This protective armor is crucial for our survival, minimizing the risk of injury to these vital structures. Bones are also essential for movement. Acting as levers, they work in concert with muscles, tendons, and ligaments to allow a wide range of motion, from the delicate movements of our fingers to the powerful strides of a runner. Furthermore, bones play a critical role in mineral storage and regulation. They serve as a reservoir for calcium and phosphorus, essential minerals for muscle function, nerve transmission, and other vital processes. The body can draw upon these reserves when needed, maintaining a delicate balance crucial for overall health. Section 4. Bone types, variety in the framework. The human skeleton is an intricate puzzle made up of 206 bones of various shapes and sizes, each perfectly designed for its specific function. These bones can be broadly classified into 5 types: long bones, short bones, flat bones, irregular bones, and sesamoid bones. Long bones, as their name suggests, are longer than they are wide, providing support and leverage for movement. Examples include the femur in the thigh, the humerus in the upper arm, and the bones of the fingers and toes. Short bones, such as those in the wrists and ankles, are cube-shaped, providing stability and some movement. Flat bones, like the ribs, sternum, and skull bones, provide protection for internal organs and serve as attachment points for muscles. Irregular bones, as their name implies, have complex shapes that don't fit into other categories. Vertebrae, which protect the spinal cord, and the bones of the pelvis are prime examples. Finally, sesamoid bones, like the patella, kneecap, are embedded within tendons, protecting them from wear and tear and enhancing leverage. Section 5. Bone cells, the master builders. The remarkable strength, resilience, and adaptability of bone tissue are all thanks to the tireless work of specialized cells: osteoblasts, osteocytes, and osteoclasts. These microscopic master builders are in a constant state of activity, ensuring bone health and integrity throughout our lives. Osteoblasts are the bone-forming cells, responsible for synthesizing and depositing new bone matrix. Like skilled construction workers, they lay down the foundation for new bone, producing a protein mixture called osteoid, which eventually mineralizes to form hard bone tissue. Osteocytes, derived from osteoblasts, are mature bone cells that reside within the bone matrix. They act as sensors, monitoring bone health and responding to mechanical stress and strain. These cellular sentinels communicate with other bone cells, directing bone remodeling to strengthen areas under stress. Osteoclasts, on the other hand, are responsible for bone resorption, the process of breaking down old or damaged bone tissue. These cells release enzymes that dissolve bone matrix, releasing calcium and other minerals back into the bloodstream. This continuous cycle of bone formation and resorption is crucial for bone remodeling and repair. Section 6. Bone formation and growth, a lifelong process. The journey from a cartilaginous skeleton in the womb to the strong, supportive framework of adulthood is a remarkable feat of biological engineering. Bone formation, known as ossification, begins early in fetal development and continues throughout childhood and adolescence. In the womb, most of the skeleton starts as a flexible framework made of cartilage, a tough but pliable connective tissue. As the fetus grows, this cartilaginous model is gradually replaced by bone in a process called endochondral ossification. During endochondral ossification, blood vessels invade the cartilage model, bringing in osteoblasts, the bone-forming cells. These osteoblasts deposit bone matrix on the cartilage framework, gradually replacing it with hard, mineralized bone tissue. Bone growth in length occurs at specialized areas called growth plates, located at the ends of long bones. Here, cartilage cells multiply and are gradually replaced by bone, allowing bones to lengthen until we reach our adult height. This process is regulated by hormones, ensuring that bones grow at the appropriate rate and time. Section 7. Bone health, nutrition, and beyond. Maintaining strong, healthy bones throughout life is crucial for overall well-being. Just like any other part of our body, bones require proper care and attention to function optimally. While genetics plays a role in bone health, lifestyle factors, particularly nutrition and exercise, have a significant impact. Calcium and vitamin D are essential for bone health. Calcium is a key component of bone tissue, providing strength and rigidity. Vitamin D helps the body absorb calcium from food, ensuring an adequate supply for bone formation and maintenance. Weight-bearing exercises, such as walking, running, and weight training, are crucial for stimulating bone growth and strength. These activities stress bones, signaling osteoblasts to build more bone tissue, making them denser and stronger. Avoiding smoking and excessive alcohol consumption is also vital for bone health. Smoking interferes with calcium absorption and reduces blood flow to bones, weakening them. Excessive alcohol consumption can disrupt the balance of bone formation and resorption, increasing the risk of fractures. Section 8. The skeletal system, an architectural masterpiece. The human skeleton is more than just a collection of individual bones. It is a dynamic and interconnected system, an architectural masterpiece that supports, protects, and allows us to move through the world. Comprising 206 bones, the skeletal system is divided into two main parts, the axial skeleton and the appendicular skeleton. The axial skeleton forms the central axis of the body, providing support and protection for vital organs. It includes the skull, which houses and protects the brain, the vertebral column, which encases the spinal cord, and the rib cage, which shields the heart and lungs. The appendicular skeleton, as its name suggests, includes the bones of the appendages, the arms and legs, as well as the shoulder and pelvic girdles, which attach the limbs to the axial skeleton. These bones are essential for movement, allowing us to walk, run, lift, and manipulate objects in our environment. The skeletal system is a remarkable example of biological engineering, a testament to the power of natural selection. Its intricate design, with its combination of strength, flexibility, and adaptability, is crucial for our survival and success as a species. Section 9. Bones in Human Evolution, a story etched in calcium. Bones are not just structural marvels, they are time capsules, preserving clues about our evolutionary past. Fossil evidence reveals the fascinating story of human evolution, showcasing how our skeletal structure has adapted over millions of years to meet the demands of changing environments and lifestyles. One of the most significant adaptations in human evolution is bipedalism, the ability to walk upright on two legs. Fossil evidence suggests that our early hominid ancestors transitioned from a quadrupedal, four-legged locomotion to bipedalism around 6 million years ago. This shift to bipedalism led to significant changes in the skeletal structure, particularly in the pelvis, spine, and lower limbs. The pelvis became shorter and broader, providing support for the upright posture, while the spine developed curves to absorb shock and maintain balance. The foramen magnum, the hole at the base of the skull where the spinal cord connects to the brain, also shifted forward, allowing the head to balance atop the spine. These adaptations, etched in bone, tell the story of our evolutionary journey from tree-dwelling primates to upright walkers. Section 10. Conclusion. Appreciating our inner scaffolding. As we've journeyed through the intricate world of bones, from their microscopic structure to their role in human evolution, it's clear that these often overlooked structures are anything but simple. They are dynamic, living tissues, constantly adapting and remodeling themselves to meet the demands of our lives. Bones are the unsung heroes of our bodies, providing the framework for our existence, protecting our vital organs, enabling movement, and even serving as a reservoir for essential minerals. They are a testament to the elegance and efficiency of natural selection, a perfect example of how form follows function in the human body. So the next time you take a step, raise your hand, or simply stand tall, take a moment to appreciate the marvel of engineering that is your skeleton. It's a complex and fascinating system, worthy of our admiration and respect. Keep exploring, keep learning, and never stop being curious about the wonders of the human body.